the wiring. So again, just a quick review here on the voltage, right? This is a tri-volt motor. There's a slash, everything left of the slash. In this case, it's 208-230, right? That's what we call low voltage. And that would correspond to this wiring diagram up here. To the right of the slash, again, in this case, it is 460 volts, and that is what's called high voltage, right? And so that's on the right-hand side, that's high voltage. So with these types of motors, they have to be physically wired to correspond to your incoming voltage. So let's take a look at the conduit box here. We can see it's already loose. We'll just take it off completely. So we'll just go through a quick example of a low voltage. Again, what does that mean in this case? Well, either 208 supply or 230 supply, both of those are considered low voltage. So if we start with the label here, we can see that 4, 5, and 6 are tied together. So we find those, and they all have a number on them. After a while, if this motor's been used a lot, and it's possible that the numbers wear out, so sometimes it's a little tricky. But in this case, we're going to tie 3 and 9. We're going to find 3 and 9. We're just going to put those together without a wire nut. 2 and 8, find those 2 wires. We're going to put those together, again, without a wire nut. And lastly, 1 and 7. We're going to find 1 and 7, put them together without a wire nut. Next, what we're going to do is we're going to bring the power in, and this is often causes a lot of confusion here. So recall, this is a 3-phase motor, so we're going to bring 3-phase in. So we're just going to kind of use this to simulate our 3-phase wire. So we've got 3 hot leads, in this case yellow, red, and black, and then the green is our ground. So your hot leads are going to be tied here. One of the hot leads is going to go to 1 and 7, another hot lead to 2 and 8, and then the third hot lead to 3 and 9. Let me show you some of the wires here. Now, in this case here, I've done a little bit of pre-work just to make it a little bit quicker. So we're going to start with the 4, 5, and 6. So we're just going to get that out of the way. So we can see that there are numbers on the wires here. So there's 4, and this one's a little trickier. So we can see way up here, that's 5. And this should be 6. 6 is, we got to be careful with 6, right? Because that's a 6 and then an underlined, because there's also a 9, right? So oftentimes that gets confused, so we got to make sure we have the line underneath that 6. We're just going to tie these together. And again, just a little quick tip here. So we're going to tie these together in the direction of the wire nut, right? So we're going to thread the wire nut on, righty-tighty, lefty-loosey. All right, so those are out of the way. And next, we're simply going to find 1 and 7, put those together, 2 and 8, and then 3 and 9. So it's just a matter of finding the right wire. Here's 8. There's 3. There's 7. 9. And the blue. Sometimes there's more than one label on there. If you cannot find it, you just sort of put that aside in process of elimination. All right, so there's 2. So let's go 2 and 8. Okay, so we're going to put 2 and 8 together. Again, we just sort of temporarily put them together here, so now we've got 2 and 8 done. And now we're looking for 1 and 7 or 3 and 9. So there's a 9, 3 and 9. Yep, I'm going to put 3 and 9 together. And then there's only 2 left. All right, so we're going to put those together, and that's your 1 and 7. So what you would do is you would bring your power in, you would come through the conduit box, we're going to bring that through the conduit box. Remember, green is ground, so there is a green ground screw inside the conduit box, so that would need to be hooked up. So next, you're just going to wire these up. Now, there's no particular order. We do have to check rotation, right? 3-phase motors can and will run backwards. Motor's going to turn the pump backwards. So we will have to check that. That's why we talked about the arrows in the beginning. So there is really no way to guarantee correct rotation on the wiring. So that's why we put a bunch of arrows on there to confirm that rotation is correct. So if the rotation is not correct, then the flow in the head will be reduced, right? So the performance will be reduced. So that's one way to measure if you can't physically see the rotation. In this case, we can. We can just bump it, see the rotation of that coupling. The other thing that we see a lot is to just make sure that, you give it a little pull test, right? You make sure that you have a good connection there, because wiring is, it's something that over time it comes loose, or even in the beginning we think that we've got it connected, but we really don't. So remember, need to connect the green ground wire. We would tuck all of this into the conduit box here and then button that up. Then again, we would bump it or jog it to just confirm rotation. So we're looking at the arrow of the coupling. So we can see that has an arrow on it. Again, that corresponds to this arrow here, not this arrow. Because if we flip this around, then those arrows are going in different directions. Remember, this is input and output, or suction and discharge, and then these two are rotation.